Hello, BC Calculus. Today we're going to be looking at the apple orchard problem. It's very similar to a popular problem called train ticket problem. Worked out the same way, but we're going to be looking at it in this setup. All right, so this is an optimization problem, which means the first question we need to ask ourselves is, what are we optimizing? Okay. Well, in this case, it's asking how many trees will maximize the number of apples, or the crop of apples, okay? So we're maximizing the crop of apples, which means we need an equation for the number of apples. So let's say number of apples equals, so we look up here, we're looking at 20 trees per acre and 300 apples per tree. So if we were thinking about how many total apples we would get from that setup, you'd have to do the number of trees times the yield. Okay? But that's not the situation we're looking at. We're starting with 20 trees and we're adding some number of trees to this field, this plot of land. Okay? On top of that, for every tree we're adding, the yield is reduced. So we need an equation for the number of trees. So number of trees, we're starting with 20 and we're adding some number of trees. And then for the yield, we need an equation as well. So it starts at 300, but for every tree we add, we're going to lose 10 apples per tree. So there's our yield equation. Now we can finally make the equation for apples. So this is going to be the equation we're working with. So our number of trees was 20 plus x, and then our yield was 300 minus 10x. We're going to simplify this down, and we end up getting negative 10x squared plus 100x plus 6,000. Now, if we're trying to maximize something, which is what optimization is, maximizing or minimizing, that means we want to find where the derivative is equal to 0, which means we need to take the derivative of this. So dA over dx equals negative 20x plus 100. Okay, so now we have our equation. Right? We're trying to find the critical points, which means we need to set this equal to 0. So negative 20x plus 100 equals 0. So this tells us x equals 5 trees. We also have to understand what this number means, because some people may just stop there. They may say, okay, this is our answer, this is what we're looking for. But we're looking specifically for how many trees per acre. Okay? This is not the number of trees per acre. This is the number of trees added to the number of trees per acre. So if we were looking for the number of trees, we have to go back up to this equation right here. That was our number of trees equation. So the trees equals 20 plus 5 equals 20 plus 5, which is 25 trees. Okay? Now, this problem can be asked multiple ways. This is why this problem is so popular. Okay? It doesn't just end there. Because they could have asked you, instead of how many trees, they could have asked you for the yield. Okay? The total yield could have been another question. So you would have done yield equals 300 minus 10 times 5. They could have asked you for the number of apples that would have maximized. So that would have been going back to this equation right here. Okay? They could have asked you for just how many extra trees would you need to add to make it so that we have a maximum, which would be that right there. So there are a couple different ways to ask this problem, and it's why these types of problems end up being so popular. It's because in this one situation, you're having to create your own equations. Okay? You're still having to take the derivative and find the critical point. And then you have to actually apply that critical value to whatever equation you need to get the answer it's asking for. Alright? So, that's it for this problem. You have one like this on your homework, as well as one of the train ticket problems, which is where this is coming from. Alright? You have a good day. See you all next time.